Vertical asymptotes and a limit involving infinity, or you can say vertical asymptotes and limit at infinity. We are taking 4 examples in this. First example I have, f of x is x times x minus 3 over x minus 3 times x plus 1. So in this problem you can see x minus 3 we can cancel, provided that x not equals 3. So then the simplified version of this one will be x over x plus 1. So this function has domain, so we cannot have x equals 3, we cannot have x equals negative 1. So that means you can take negative infinity to negative 1, then negative 1 to 3, and then 3 to infinity. So this is the domain of this function. So our next question is, what happens at those points? When x equals 3, what do we have on the graph? Since we can cancel x minus 3 from numerator denominator, that means on the graph at x equals 3 we have a tiny hole, but at x equals negative 1 we have a vertical asymptote on the graph. So let us look at the graph in our calculator. So when we graph this in the calculator and I'm typing the function, we have to do it very carefully. In the denominator I have 2 factors, so I open another additional parenthesis. So then x minus 3 is one factor, x plus 1 another factor, and we combine this with this additional parenthesis. Now let us graph it. So clearly you see at x equals negative 1 here, this is the vertical asymptote. So the graph on the right side of negative 1 going all the way to negative infinity, you can see here. And on the left side of negative 1, the graph goes all the way up. This is positive infinity. So now if we ask additional question on these, what happens to the limit of this function when x approaches to negative 1 plus, then you will see that this side graph goes all the way down, which is negative infinity. But on the left side, when you say negative 1 minus left hand limit, then the graph goes all the way up. That means it goes to positive infinity. All right, so we see all this, but another important information we need to see what happens at x equals 3. So you can just trace at x equals 3, you will see nothing, but look like graph goes all the way. Look at here. So what happens at x equals 3, there is a tiny hole on the graph. With your bare eye you don't see it, but limit exists. So that exactly will happen in our example 3. So let me complete example 3, then I will go to example 2 and example 4. Example 3. So as we said, since x approaches to 3, not exactly 3, we are comfortably cancelling this term here and this here. Now when you see x is 3, so you got 3 over 3 plus 1 is 4, so 3/4. So we are done this part. Now let us look at the second one. Second one, you see, we cannot cancel anything on these. So my domain will be where x not equals 3 and x not equals 1. Now I have a negative in here. And in both the places we have vertical asymptote. So we can see a vertical asymptote at 3 and vertical asymptote at 1. Let us graph it in the calculator and observe all this. So we are following same way. So first numerator x times x plus 3. If you don't keep within parentheses, it's fine in the left side. But when you put a division sign like this, you must put all the factors within parentheses. Let us graph this and see what happens. We are expecting 2 vertical asymptotes at 3 and at 1. Exactly, you see here, one vertical asymptote at 1, another is at 3. Now what happens, let us talk about limit on this close to 3. So when I'm at 3 in here, if I say 3 plus, that goes all the way up, that means positive infinity. And you can see another portion graph is here. If you want to see better, maybe go to the window, make your y minimum little more, then you can see better. Okay, y minimum. So graph this again. You can see here. So this one is going, when you say 3 minus, that means left hand limit goes all the way down, which is negative infinity. And then 3 plus goes all the way up, positive infinity. This graph here, you see that goes up like this. So when you say 1 plus, then goes down like this, negative infinity. 1 minus goes up in here. If you want to see better graph, maybe you can go to window and reduce this a little bit, because we know we are searching at 1 and 3. So if you say -1 to maybe 5 will be fine. Yeah, you can see better. So this is 1 in here. So 1 plus goes all the way down, negative infinity. And then 1 minus on the left side goes all the way up, positive infinity. So we got this one. Now let us look at the limit when you are looking at 3. So when I say 3, so you have to check on the left side and right side of 3. So we said 3 plus here goes all the way up, positive infinity, and 3 minus all the way down, negative infinity. So therefore, limit for this one at 3 does not exist. And we are done in this case. So we just double check. Now we said that this limit does not exist. The reason is, when I say 3 plus, you can look at the graph here. It goes all the way up, positive infinity. And 3 minus in this side goes all the way down, which is negative infinity. And that's why I said that limit does not exist. And we are done.